fifth graders. My name is Mrs. Compton, and I'm going to get to work with you this school year on math. And I know some of you might recognize me from last school year working in your classrooms or even on distance learning videos. And we get to do that again this year, and I'm so excited to be able to do that. I'll either be working in this room kind of on some of the fifth grade big ideas, or you might even see my computer screen sometimes. But I just wanted to take a minute to introduce myself and tell you how excited I am to hear your ideas as we get going in our school year for distance learning. All right, so up next, your very first lesson.
We're going to check out this place value chart. You've probably seen one of these things a million times, but you may not know how useful it is. So I want you to notice with me that there are different colors on this place value chart. And each color is showing us a period. These are grouped together by color. So each color is representing its own period. So here's the thousands period. Oops, I almost wrote thousands instead of period. And here's the millions period. Now, you probably already know that the millions period is worth the most out of the ones here on this chart. But you probably even know that the 100 millions is worth the most in comparison to the other ones in the millions period. So between the millions, the 10 millions, and the 100 millions, this one is worth the most. It also is the darkest shade of turquoise. So the shades also mean something in the colors here. So you could check out the thousands. So the 100,000s is worth the most, so it has the darkest shade of green. This is the middle for the thousands, the 10,000s. And then the thousands is worth the least, so it has the lightest shade of green in that period, right? Over here, I'm going to call your attention to the decimals. It's kind of reverse. So this blue is the darkest blue, and this one should be the medium shade, and this one should be the lightest. I know it kind of looks maybe not exactly like that on the computer screen, but just roll with it. So let's check this out. If I put a 1 right here and I want to talk about money, you probably know that would be worth $1, right? And if I put a 1 right here in the tens column, you probably know that would be worth one $10 bill. So you could probably make the connection between the 1 in the ones column and the 1 in the tens column, and then make that connection all the way to the hundreds column. That would probably, in your mind, be worth one $100 bill, right? So let's check some patterns here. Let me change my color. So from here to here, from here to here, so I'm looking at the one from the ones column to the tens column. How many $1 bills would you need to make $10? Well, you'd have to count out a $1 bill 10 times, right? And how many $1 bills would you need? Actually, let me switch that. How many $10 bills would you need to make $100 bills? So if you wanted to have a 1 right in the hundreds column, how many would you need? Well, you'd have to count out 10 $10 bills to make $100 bills. All right, so let's check this part out. How many $1 bills would you need to make $100 bills? Well, you'd need to count out 100 of them, right? So maybe you even noticed that 10 times 10 is actually 100. So you may have realized, okay, I can see that 10 times 10 is the same as 100, so these things are all related. Now, this pattern always holds true. So every time you move one column to the left, you increase by 10 times the amount. If you move 2 columns to the left, you increase by 100 times the amount, and so on. Now, the reverse is true when you're talking about going to the right. So let's go back to money. Who doesn't love to think about money? All right, so I'm going to put a 1 right here. What would the value of that be in money? Some kids probably said $10. Some probably said a penny, but it's actually worth 1 dime. Let me write that up here. It's worth 10 cents. And how many dimes do you need to make $1? Well, you probably know that you would need 10 of them, right? So the pattern would hold true if I went from here to here. I still need to count 10 dimes out to make $1. But what if I'm going the other way? What if I want to go from the ones place to the tenths place? Okay, so I'm going to erase these for right now. So now I'm going to go the other direction. I'm going from the ones place to the tenths place. All right. How many, or how would you break up a $1 bill to make 1/10 of that? Well, you'd probably say you would have to break it up into dimes, and you would need 10 dimes, right? So you would have to divide by 10. Same thing. If you're going from a $1 bill to all pennies, this is like the penny column over here. 1 cent. Ooh, you can see that pretty well. Let me copy the 10 cents. It's red. There we go. So hundredths are like the penny column because you need 100 pennies to make $1. So a penny is 1/100th of $1. Okay, so you would have to divide your dollar into 100 pieces or 100 pennies to make 1 cent. That's a lot of thinking to do. Lots of patterns. But the same thing is always true. When you move 1 place to the left, it's times 10. When you move 2 places to the left, it's times 100, otherwise known as 10 times 10. You can see that here, or 10 to the second power. If you move 3 times, 1, 2, 3, it's times 10 times 10 times 10, otherwise known as 10 to the third power, or 10 times 10 times 10 is 1,000. They're all the same right here. These are all the same things. You can just kind of see it broken down, right? All right, there's more to come. I'm going to help on multiplying and dividing decimals in the next video. All right, see you next time. Bye.